All right, this is section 4-3. We're going to do triangle congruence by ASA and AAS. So again, we're going to try to prove two triangles congruent by using three pieces of information. So let's start doing vocabulary review. So let's cross out the figures that are not triangles. All right, this first figure is a hexagon, not a triangle. This figure here is a quadrilateral, and this figure here is also a quadrilateral. A triangle is a polygon with three sides. A triangle with a right angle is called a right triangle. Okay. So remember, corresponding. Other forms of the word is to correspond or correspondence. Corresponding means similar in position, purpose, or form. In math, congruent figures have congruent corresponding parts. Okay, so we're going to draw a line from each part in triangle ABC in column A to the corresponding part in triangle XYZ in column B. So line segment BC is going to correspond to line segment YZ. Angle A is going to correspond to angle X. Line segment AB is going to correspond to line segment XY. Angle C corresponds to angle Z. Line segment AC corresponds to line segment XZ, and angle B corresponds to angle Y. Okay, so our new postulate in this section, angle side angle, and it states if two angles are the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent. So here it is in symbols. If we know angle A is congruent to angle D, sides AC is congruent to side DF, and angle C is congruent to angle F. So angle to angle, side to side, angle to angle, side, angle. Then I know those two triangles must be congruent. All right, how is ASA different than SAS? Okay, so the ASA postulate uses two angles and an included side. And the SAS postulate uses two sides and an included angle. Okay. So which two triangles are congruent by ASA? And let's explain. Okay, so number 11 here. Name the triangles, list the vertices in corresponding order. List the vertex with the one arc first, the vertex with the two arcs, and then the third one, right? All right, so triangle GHO, triangle INF, and triangle CAT. Order matters. So angle G is congruent to angle I, which is congruent to angle C. Angle H is congruent to angle N, which is congruent to angle A. Line segment HG is congruent to line segment NI, which is congruent to line segment AC. The congruent sides that are included between congruent angles are HG and AC. So the congruent statement is triangle GHO must be congruent to CAT. All right, so we state triangle GHO and triangle CAT have two pairs of congruent angles and a pair of included congruent sides. All right, so let's try a flow proof using ASA. So we're given angle CAB is congruent to angle DAE. Notice the marking. Angle side segment BA is congruent to the segment EA. Angle B and angle E are right angles. So let's prove triangle ABC is congruent to triangle AED. So we were given angle B and angle E are right angles. Okay. We know all right angles must be congruent. So angle B is congruent to angle E. We were also given line segment BA is congruent to line segment EA. And we were also given angle CAB is congruent to angle DAE. All right, so putting these together, ASA, okay, triangle ABC must be congruent to triangle AED. Here we go. So theorem 4-2, angle side theorem. So if two angles and a non-included side of one triangle are congruent to two angles in the corresponding non-included side of another triangle, then the two triangles must be congruent. So in the diagram here, the non-included congruent sides of triangle ABC and triangle DEF are side AC and side DF. All right, let's try number 3. We're going to try to write a proof here. So given angle S is congruent to angle Q, RP bisects angle SRQ, we want to prove triangle SRP is congruent to triangle QRP. So how do you know which angles in the diagram are corresponding angles? So they have the same number of arcs, would be the way I would do it. Okay, so let's complete this proof here. We know from the given angle S is congruent to angle Q. We know RP bisects angle SRQ. So if that is true, then SRP must be congruent to triangle QRP, definition of an angle bisector. All right, we also know RP is congruent to itself, reflexive property. So watch this, look what we just given here. Angle, angle, side. So therefore, triangle SRP must be congruent to triangle QRP. Oops, let's erase that, make that QRP, and I think we would be good to go. Okay. So are triangle PAR and triangle SIR congruent and explained? So the congruence marks show that angle IA is congruent to angle I, and segment PR is congruent to segment SR. So what other corresponding parts exist? We know also angle PRA is congruent to angle SRI because they are vertical angles. Okay, so are these two congruent? Yes, and why? AAS. Okay. So suppose angle E is congruent to angle I and line segment FE is congruent to line segment GI. What else must you know in order to obtain triangle FDE is congruent to triangle GHI? All right, so let's mark up the triangle. So this must be D, this must be E, this must be I, this must be H, and this must be G. So I need two pairs of congruent angles and a pair of non-included congruent sides. Okay. So, oh, I'm sorry, ASA. ASA would be included angle, the congruent sides. For AAS, I need two pairs of congruent angles and a pair of non-included congruent sides. So if I want to use ASA, I need angle F and angle G to be congruent. If I want AAS, I need angle D and angle H to be congruent. All right, and that is the end of the section.